Hi, this is Jordan Stevens and Danica Dvoracek doing Section 1, Problem 4. Unfortunately, we were not able to meet this week to do these videos together, but we each are taking one of the problems. So Danica took Problem 3, and I'm taking Problem 4. So with this problem, we are first of all establishing that there are 2 points, A and B, that are randomly generated between 0 and 1. So there's an x-coordinate and a y-coordinate that are generated between 0 and 1, and that's why there's this squared right here. So based on that, the distance between A and B is just the distance formula, and that's what we're trying to calculate in this first problem, is the red line right here, the distance between point A and point B. As we go on, we want to calculate the mean and variance of the distance. So to do this, we just do some pseudocode. For 1 to 5,000, we randomly generate point A, randomly generate point B. This is generating x1, y1, x2, y2, calculating the distance between A and B. That's just using the distance formula, and recording the distance. After we do this, we can use the mean function and the variance function to find the distance. So in MATLAB, this is the pseudocode written out in MATLAB. We randomly generate a x1, a y1, an x2, and a y2. We use the distance formula labeled here, and we use the mean and variance functions. So as we see below, we see that our mean is 0.52, and our variance is 0.06. So as we get into the third part of this problem, we're trying to find where the distance between point A and B is greater than 1.4. So we can't actually do this with Monte Carlo because we just need an insane amount of actual numbers to generate to actually formulate this area, because this area is very, very small, because the distance between each one of these points is like 1.4, very, very close to 1.4. So this graph is not to scale. So basically what we need to do is we need to solve it analytically. We need to solve it geometrically. So we know that the distance between each one of the points is 1.4. So that's a circle with a diameter of 1.4. And then the radius is 0.7. That's how we got this value. And then we know that this is 0.5 since this is a unit square and this is half the distance. So we used this square right here, and we used geometry to basically figure out these red areas right here. So area of a triangle is 0.5 times this one. We got this purple value from using the Pythagorean theorem with 0.7 as the hypotenuse, and this is as the adjacent side. So we did 1/2 base times height to get this area. Got this area from the same exact thing since these are both the same. And then we had to use the arc formula for this area right here. To find the arc formula, you had to find the angle of this triangle, times it by 2, minus 90 degrees, to figure out this angle right here. And then it's simply just the 1/2, the radius, squared times the angle. And that's how you get this area right here. And then, since we know that this is the area that we want, we add all three of these areas up and do 1 minus that. We can see this math right here. We see that it equals 5.0679 times 10 to the negative 5. And then for the last part of the problem is we know that we want a point after it's generated in one of these 4 squares, and then we want one of the point in the opposite corner. So basically what we need to do is we need a probability of A and B. The probability of A, which is the first point falling in any one of these squares, is just all 4 of the areas added up. And then we do, to find the area, probability of B is just the adjacent square, which is only one of them. So then to find the probability of A and B, you need to do 4 times P times P. So P is just the area of one of these. And we got 1.0273 times 10 to the negative 8th. And here's the code. We did it both ways. We did formulating the area of it, and then formulating the area based on the other areas minus that 0.25 in that area. And then our probability is this 4p times p, and that is this value right here.